Hello friends. Okay, so this is a quick review of your basic exponent rules. I designed this review series just to help you review maybe for like a math placement exam like ALEKS, but honestly you can use this if you forgot that particular topic for a math class. Sometimes I talk about ALEKS, so just ignore that if that doesn't apply to you. Okay, so let's talk about the exponent rules. So we have the three major ones: the product rule, the power rule, and the quotient rule. So let's go through each one. So starting with the product rule. Okay, so this x here, this is called the base. So if you have this same base and then you have these exponents m and n, what you're going to do is you're going to add them versus the power rule. So if I have this x to the m with parentheses and then to the n, then in this case, you're going to multiply the exponents. So these are two really commonly mixed up rules. And so one thing I always recommend is that make sure if you're studying for a test, whatever reason you're using this video, knowing these three rules is super clutch for any math that you need to do. And I find that some students are just visual. So if you are somebody that mixes up these two things, just write these down on whatever it is that you're working on so that you have that visual cue if your brain's starting to play tricks on you. Okay, and then for the quotient rule, so if I have x to the m over x to the n, so the idea here is that I would take m minus n, so the top minus the bottom. Now, this doesn't always apply. I'll show you some examples in a few minutes, but for now, let's just say that's the rule. The other favorite set of exponent things are the negative exponent rules. So for instance, if I have x to the negative n, so imagine that this x to the negative n is over an invisible 1. And so what I want you to think about is with these negative exponents, they're all about reversing wherever that base is. So in this case, since the base is technically in this numerator, we're sending it to the denominator. So x to the negative n equals 1 over x to the n versus 1 over x to the negative n. So now in this case, this is going to bring up that base of x, and this will just equal x to the n. So I'll get rid of the blue writing just so you can kind of see the difference now. So I've got x to the negative n is 1 over x to the n versus 1 over x to the negative n. See how it brings it up top versus bringing it down to the bottom. And so now for this last one, I have x over y to the negative n. So negative exponents are just all about reversing whatever position you're in. So in this case, I'm going to reverse the position of both the x and the y. So now this will become y over x to the n. So negative exponents, so the thing that a lot of people forget with these are that they have nothing to do with negative numbers. They're all about position of your base. And so whatever they're attached to, if it was in the top, it needs to go to the bottom. Here I have something on the top and on the bottom, so it just flips the whole thing. So you really want to repeat that to yourself if you're one of those people that wants to turn them into a negative number. So now what we're going to do is we're just going to go ahead and use these rules. And by the way, I offer free PDFs of notes on this video, plus all the problems that I'm going to go through. So in general, I think you're more likely to remember this material if you write it down. So if you would like to use my free PDFs, you can just go to divideandconquermath.com and then go to the review section and then look for this topic name in the review section. And you can find all of those problems here to work alongside the video. Okay, so let's jump into this now. So I've got 2 to the second times 2 to the third. So it doesn't matter what type of base you have. You can have a letter or you can have a number like we do in this case. And so in this case, since I've got a 2 and I've got a 2, I can just think back to what exponent rule does that look like. So instead of having x's, now I have 2's and then I have numbers up here. So I'm just going to add the exponents. So this is also why I say having this written down next to you. Some people are just visual people. And so you might have a better sense of what to do with the exponents, especially if you're reviewing this. You might have a better sense of what to do with a problem like this if you have this written down next to you as a visual cue. Okay, so that being said, I'm going to go ahead and add the exponents. So this is 2 to the 5th. And in this case, I can evaluate 2 to the 5th. So what is 2 to the 5th? So 2 to the 3rd is 8. 2 to the 4th is 16. So 2 to the 5th is 32. So you can just kind of compute that. Okay, so then for b, I have x to the 7th times x to the 8th. So actually I have B, C, and D here. So these are all just using these exponent rules. So what I would recommend maybe is that you just try these three if you're reviewing this. You'll remember this more if you try it on your own. So maybe pause here, hit play when you think you've got an answer. Just write them down real quick. Okay, so now I'm going to go ahead and add these exponents. So this is definitely the product rule. So this is going to be x to the 15th, okay? And then for the next one, so I have x to the 4th to the 7th. So that is mimicking our power rule. So I will need to multiply these. So this is going to be x to the 4 times 7. So this will be x to the 28th. And then finally, I've got x to the 6 over x squared. And so now I can use the quotient rule. So I can take the top minus the bottom. Okay, so this will be x to the 6 minus 2, and that equals x to the 4th. Cool. So let's keep going. Let's make this a little harder. So now I want to talk about some of these other weird cases. So let's take a look at E here for a moment. So technically the rule is that you take the top minus the bottom. So I want to just review. If I do 3 minus 8, that will give me x to the negative 5th. Okay, so one of the things when working with exponents is that in general, you don't want to leave your answer as a negative exponent. There's very few places in math where they want you to leave this as a negative exponent. So one of the things that you want to think about then is either you can rewrite this as 1 over x to the 5th, but from where I'm sitting, I think that this is a little bit more work than it needs to be. Okay, so let me just show you an alternative way that you could do this. So let me clear this out. And let's talk about another way that we could look at this. So the rule, usually when we first talk about this rule, this quotient rule, the thing that we're assuming is that m is greater than n. But this rule works even if that's not true. It's still the case. But like I said, we typically don't want to end up with a negative exponent. So another way you can remember this is that you look at the two exponents. Where is it bigger? In the top or in the bottom? It's definitely bigger in the bottom, right? And so because of that, what you can do is you can just say, okay, I know that when I cancel out these x's, since there's more in the bottom, this needs to end up in the bottom. And so you can actually just reverse the subtraction this way. And so then this becomes 1 over x to the 5th. And so I think that this is just a little bit more efficient than running into a negative exponent and so on and so forth. So just something to think about. Okay, so let's move on to f now. So for f, I have 2 to the negative 3rd. So one of the things that you want to get in the habit of is that when you see a negative exponent, first just do what it's asking you to do. Remember, a negative exponent has nothing to do with negative numbers. It's all about flipping the position. So if you're one of those people, and there's always tons of people that are like this, where their brain just wants to make this into a negative number, really force yourself, tell yourself over and over, this is about flipping the position. Flip the position first and then make a decision about whether it should be negative or not. So I have now flipped this to the bottom and there's no negative anymore, right? So now I can just evaluate what is 2 to the 3rd. So this will become 1 over 8. Okay, cool. So the other thing that I want to talk about is with G here. So this is another really classic kind of situation that comes up with exponents. So here you'll notice I have x to the negative 5th, y to the 3rd, and then z to the negative 8th. So one of the other things that you just kind of want to review and remember are that the things that have negative exponents, so those are going to be the things that are sent to the denominator. And so we are going to practice this a little bit in this video. So the y to the 3rd stays on the top, and just the letters that have the negative exponents get sent to the bottom. Okay, cool. So now let's add on a little bit more to this. So now I have h and I here. So now I've added in more elements to this. Of course, this is always where exponents go. We want to make them harder. So once again, I would just say pause here for a second, think about these two, and then hit play when you're ready. You'll get more out of this video and out of this review, and you'll retain more if you try it on your own. Okay, so starting with h here. So I notice that I have a 3 and a 2, and I'm multiplying everything together, so I can just take 3 times 2, so that's 6. And then I have my x's and I have my y's. And since everything's just being multiplied together, this is really just a slightly more complicated looking product rule, right? Because I'm just multiplying everything together. So what I'm going to do then is I'm just going to add all of these. So I'm going to add the 3 and the 5 and the 6 and the 7. So this is going to be 6x to the 8th and y to the 13th. So for the next few problems, we're going to just make slight changes in what happens with the exponents, because I think this is really the best way to teach you or to review with you why exponents can be tricky. So let's starting with I here. So one of the things that you want to get used to is, so when I have a whole set of stuff inside the parentheses to an exponent, one thing that you have to kind of make sure that your eyes are adjusted to is for you to apply that exponent to each part in the parentheses. So I count 1, 2, 3 things, and so that 2 should apply to everything. So the thing is that oftentimes people will forget that 4 needs to be squared. And the best way to prevent yourself from making this error and not doing anything with the 4 is to force yourself to write that you need to have 4 squared. Now, for the rest of these other exponents, they're all getting multiplied by 2 because this is just an application of the power rule. So the answer here is, or sorry, I said power rule, right? Yeah, I said power rule. Okay. And so to finish this will be 16 x to the 6th, y to the 4th. Okay, so in the event that you forgot to write the 16, this is like a really common error. I actually used to make this error all the time when I was in algebra. So the way that I would prevent myself from doing that is I would actually force myself to write out 4 squared. If I forced myself to see that, then I wouldn't forget to square the 4 or cube the 4 or whatever this number says out here. Okay, so now what we're going to do is we're going to make slight little changes to this problem just so you can kind of see the complexity of exponents and different ways that you can handle this. So I have here examples J and K, and you can see that I have a negative exponent here versus a negative exponent here. So the thing with exponents that makes them a little tricky is that there's actually now, once you get to this point, there's more than one way to deal with these problems. And as long as you get to the same answer that I have, it's all good. But I want to talk about just different ways to kind of think about this. So it totally depends on where that negative exponent is in terms of how you might want to handle it. So starting with J here, so one way that I could handle this is I could just deal with the fact that I have this negative exponent. So I could just take my entire set of parentheses and just take this entire set, right? What does the negative exponent mean? It means send everything to the bottom. So I could just send everything to the bottom like this and then move forward with the problem. And then this is very similar to the previous one, right? But technically, the other way that would be totally valid to evaluate this would be to apply that -2 to all the parts of the problem. But then you would have 4 to the -2nd, x to the -6th, and y to the -4th. So to move forward with this, you would then have to clear out the negative exponents. So you would have to eventually write this so that it looks like this. So from where I'm sitting, I think that this is a little bit more complicated. However, some people, this is the first thing that their brain goes to, and that's totally fine. And that's what I mean with, like, there can be more than one way to do some of these problems. And it really depends on how the problem is set up in terms of what is the easiest approach. And a lot of times, like, you know, I'm a seasoned, like, math person, right? So I look at this and I'm like, oh yeah, I can see what the easier way is. So if you're not sure, like, plowing ahead with this is totally fine. It's just a little longer, but it still gets you there, and that's all that matters, right? Okay, so let me clear this out. So I'm just going to finish the problem in this format. So what I'm going to do is I'm going to rewrite this as 1 over 4 squared x to the 6th, y to the 4th. And by the way, in that previous step, this would have been the next thing that you would have done anyways. So now the two methods are equivalent. So this is just now going to equal 1 over 16 x to the 6th and y to the 4th. Okay, now I've made another little adjustment where I have x to the -3rd and this is still to the second. So how is that going to change things? Well, if you want, you could think about this for a second, and you could just make an attempt at this and then, hit play when you're ready. I think that would actually be the best way to do this. So there are two totally valid methods for this one. I'm going to discuss both just to kind of give you some ideas. So one way would be that you could keep the set of parentheses for a moment, and you could just send this x. So it's only the x that has the negative, right? So this is the other thing that messes with people. This 4 does not have a negative exponent attached to it, right? The negative exponent only moves exactly what is attached to. So it is only going to move that x. So you could either set up the problem like this, or you could go ahead and do that approach where you apply that 2 to everything. So the alternative would be 4 squared. So this will be negative 3 times 2. And then this is still just that y to the 4th, 2 times 2. So again, it's like a tomato thing. And actually, in this case, I don't think it matters which way you want to go with this. So I'm actually just going to finish it this way. But you will get the exact same answer if you decided to mess with the inside of the parentheses first. So let me just get rid of this and let me finish. And whichever way you went is totally fine. But so now what this is going to give me is 16 x to the negative 6 y to the 4th. And so again, only that x has the negative exponent. I know there's a really common temptation to be like, oh, but it's attached to the 16. The 16 had its own exponent, right? The 16 was 4 squared. This did not have a negative exponent on it. Do not touch the 16. So I am only going to send the x to the bottom. So this becomes 16 y to the 4th over x to the 6th. And so this is why I say, exponent problems, they can get a little complicated. So what we're going to do in the rest of this video is work on these weird little cases in hopes that this kind of hones your ability. So, by the way, if you're finding this helpful, I would love it if you would hit that like button or leave a comment, subscribe to the channel, or tell your friends. I love it when people hit like. It tells me that I'm doing something right. And hey, if you don't like the video, feel free to leave me a comment with some feedback. No problem. Okay, so I've got another one here. So now I've got negative exponent here and negative exponent here. So again, challenge yourself here for a moment. Why don't you try this and then hit play when you're ready? Okay, so I've told you that there are multiple ways on how you can attempt this. I am just going to plow forward with one way now, and we should have the same answer. So what I'm going to do in this case is I think I'll go for the approach where I just apply that exponent to each part. So this is going to be 4 to the negative 2nd. So notice now, this is a number that has a negative exponent. So this will have to go to the bottom. This will be x to the negative 3rd times negative 2, and then y squared times negative 2. Okay, so if I work through this, this becomes, I'm going to leave this alone for a second. This is going to be 4 to the negative 2nd. I don't mess with numbers until I get rid of the negative exponent, so I'm just going to leave that alone right now. X to the 6th, so negative 3 times negative 2 becomes positive 6, and then 2 times negative 2 is negative 4. So the things that will get sent to the denominator in this case are these two pieces, okay? And so my final answer will be x to the 6th over 4 squared y to the 4th, and that's x to the 6th over 16 y to the 4th. So there's a few ways on how you could have done this, but this should be the final answer that you should have gotten. If you didn't get this, I'm going to put money on you probably missed a negative exponent somewhere. Okay, so let's keep playing around with negative exponents. I've got a handful of tricky examples left here. So here for m. So now what do we do with this type of situation? So this is another thing you got to get used to with negative exponents. Sometimes you can have a ton of negative exponents kind of floating around. So when you have the same variables, boom, 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 like we do here, what I say is before you do anything else with the variables, when you have multiples on top and on bottom, first just put things where they belong, because it's just so confusing to look at this otherwise. To do the quotient rule as it is, it just becomes too many negatives. So just force yourself, okay, I've got x's on top and on bottom, and there are negative exponents, before you do anything else, just put everything where it belongs. So this y to the negative fourth needs to go to the top. This x to the negative fourth needs to go to the bottom. Leave those numbers alone. They don't have a negative exponent. So I've got the 5, the y to the 7th, and now I'm going to bring up that y to the 4th. And then I've got 10, x to the 3rd, and I'm going to bring down that x to the 4th. And so you can see, once you get rid of the negative exponents, it becomes more clear as to what you need to do. It's not quite so dizzying with all those negatives. This is, I think, really where it gets really kind of tricky. So let's see. The other thing I can say is that this 5 will cancel out with this 10, and the 10 will become a 2. So the top, I can add those exponents. This will be y to the 11th, and the bottom, this will be 2x to the 7th. Okay. So for the remainder of this video, I just have more tricky things like this. So we're just going to keep plowing ahead with this, and then I have more practice too on top of this. But I'm really trying to make sure you've got a good breadth of negative, or just different negative exponent problems, really. So for this one, yeah, you know what? I'm just going to say, give this one a try. It looks kind of dizzying, but I actually promise it's not too bad once you get a second to think about it and look at it. Give it a try. Hit play when you're ready. Worst thing that happens is you get it wrong and you learn something. Okay, so this is one of my favorite problems to give because there's A, B, C, D, E, F, G, H. So there are no common variables. So the only thing that this is actually asking you to do is to move things where they belong. So this A and this C, those both need to move to the bottom, while this E, this F, and this H are the only things that need to move. So everything else needs to be left alone. Again, the 4 doesn't have a negative exponent, right? So it does not move. So the answer to this one will be 4b cubed d to the 7th, and then I'm going to bring up that e to the 8th and that h to the 3rd. And then in the bottom, let's see, I had that g. Oh, I forgot the f, sorry, and the f squared. And then in the bottom, I have g, and then a to the 3rd, c to the 7th. Now, one of the questions I usually get, especially with this one, is does it matter what order your letters go in? It doesn't matter. It just has to be, these letters have to be on top with these exponents, and these have to be in bottom with these exponents. Okay, so let's keep going with this. So for each of these, I am just going to challenge you. Just, pause, give it a try. Worst thing that happens is you get it wrong, and then you'll learn something. It's a lot better to try something than to watch somebody do it on YouTube correctly, because I know how to do this. Like, you'll get more if you practice it. Okay, so in this case, now this is kind of an interesting one because we've got a lot going on here. So there is no shame in ever breaking this up. So this is a negative number in parentheses. So I want to respect that. I've talked about the importance of negative numbers in other videos. You can check out my video on the order of operations if you want. So for this one, I'm going to leave the parentheses around it for a second, and I'm just going to apply this 3 exponent. And then for the rest of these, so I've got -3 times -3, so that's going to be -9. That'll be 4 times 3, which is 12, and then -2 times 3, which is -6. So remember, 3 is going to get multiplied by each one of these, okay? So here is what I'm left with. And so then let's see. -3 to the 3rd. I'm going to blow this out for a second. So -3 to the 3rd means -3 times -3 times -3. Negative times a negative. -3 times -3 is +9. +9 times -3 is -27. So this is a negative number now, not because of the exponent, right? It's because we started with a negative number. So this is kind of also where people's brains will start to, I don't know, I feel like they like melt a little bit because it's like a lot of stuff going on. But you have to keep the difference between a negative number versus a negative exponent. So this is -27. That's not an exponent, right? And what else should happen now? I have this y to the 12th, and then what do I have? I have x to the 9th and x to the -6. Those are the two things that need to get sent to the denominator. So this will be send x to the 9th and x to the 6th to the bottom. Okay, cool. So -27, no exponent on this, right? It's just a negative number. It had a positive exponent. This can totally mess with people's heads, so I want to make sure I just kind of highlight this. Okay, so I've got another very similar one just to keep kind of getting you. If you're struggling with these, I think that these are hard. So I want to just give you a lot of these. Practice makes perfect with this, and sometimes this takes a lot of practice. So again, pause here, give it a try, hit play when you're ready. Okay, so I'm going to do the exact same thing. I am going to rewrite this as -5 squared, and then I'm just going to multiply 2 times each one of these exponents, right? So this is a number versus these are exponents. So this becomes x to the -4th, y to the 8th, and z to the 6th. Okay, so I'm going to think about what do I do with this -5 squared. Well, with this -5 squared, that is going to be -5 times -5. And so that will equal +25. So because it is being squared and it's in parentheses, this stays positive, or this will become positive. So this equals 25x to the -4th, y to the 8th, z to the 6th. And so then the only thing that needs to get sent to the denominator is this x. The 25 does not have a negative exponent attached to it, so this becomes 25 y to the 8th, z to the 6th over x to the 4th. Okay, so I've only got 2 more examples, kind of still honing these skills. So once again, I've got another one here, no parentheses this time. Just give it a try, hit play when you're ready. Okay, so before I even get into this, these 2 things need to go to the top, while this thing here needs to go to the bottom. So I am just going to put things where they belong, because again, I'm in this situation where I have x's on top and on bottom with negatives. It's just too much. I see people just fly through this and then they make an error. So exponent problems are actually a lot more detailed. They look small, but they are a lot more detailed than you would think. Okay, so the 10, leave it alone. The y to the 7th, I'm going to leave it alone. And then I'm going to bring the x to the 4th and the y to the 3rd to the top. While in the bottom, I'm going to bring down that x to the 3rd. So it was just the x to the -3rd that needed to come down. Okay, so now I have a better picture of kind of what's going on here, and I'm going to reorganize everything to make it a little nicer to look at. So this is going to be 10 x to the 4th, and then I'm going to put the y's together, y to the 7th and y to the 3rd, and then 2x to the 3rd. Okay, so now I have a much better picture of what's going on. I've organized this. The devil is in the details with these exponent problems. So now I can see that with these x's here, there are more x's in top than on bottom, so I can use the quotient rule. While with these y's, I can add them. And then this 2 will actually cancel out with the 10 and just become a 5. So now I'm going to have 5 x to the 4 minus 3 and y to the 7 plus 3. So this is going to be 5xy to the 10th. Okay, and so here's our last one for this video. So now I've kind of got a little bit of everything in this. So again, if you want, just maybe pause for a second, give it a try, hit play when you're ready. Okay, so like I said, it's a little different every single time, but one of the principles that I think I really work with is that when I have 2 of the same letters and negative exponents, this is just too much for me to look at. So I want to just figure out what is going on with the y's here before I deal with this squared thing. You could have squared everything first and got to the same thing. Just for me personally, this is one of my principles. If I have this kind of rules over everything. So let's start there. So this will be 5x to the 3rd, y to the 3rd, and then I'm going to bring that y squared up. And then I have this z squared in the bottom. Okay, so the nice thing is then, before I square the outside here, what I can do is I can add these. So this will be 5x to the 3rd, y to the 5th over z squared, and now I can square everything. So now I'm going to square everything. So remember, you need to square the 5, and then you're going to multiply each one of these exponents by 2. So in the end, this will equal 25 x to the 6th, y to the 10th over z to the 4th. Okay, cool. All right, so that brings us to the end of this video, but hey, you cannot master math by watching a ton of YouTube videos. You do have to practice it. So to help you with that, every review video that I make has a companion additional practice problem set. So I know we went through some really hard problems here, but this is a hard thing to kind of master. So I strongly recommend that you check out my additional practice problems. So my additional practice problems also have a PDF of problems with an answer key, so you don't even have to watch the video if you don't want to. But I do have a video showing you how to work any of the problems if you aren't sure. So what I suggest is that you try that set of problems and see how well you know the topic. If you're interested in that, you can go to divideandconquermath.com and go to the review section. There's no strings attached, it's all for free. And by the way, my review series has many other topics in it, not just exponents. So each topic includes a refresher video, like what you just watched here, and then the practice problems like I was just talking about with the answer key and the worked out solution. So I kind of have everything to cover your bases if you're trying to review and master a topic. So everything's at divideandconquermath.com. Just go to the review section and everything is available for free. Okay, so I will talk to you guys hopefully in another video. Hopefully we will see each other in the practice problems. Bye.